Fresh observations of the mysterious interstellar visitor 3I Atlas are revealing properties that, well, challenge everything scientists thought they knew about this cosmic wanderer. What initially appeared to be a straightforward comet from another star system is now displaying characteristics that have some researchers questioning whether we're dealing with something far more extraordinary. The object's bizarre orbital path, suspicious timing, and anomalous behavior patterns are sparking intense debates in the astronomical community. Could this visitor be more than just another space rock drifting between the stars? Fresh observations reveal mysteries. The latest observational data from 3Y Atlas has sent shockwaves through the international astronomical community, revealing properties that really defy conventional understanding of interstellar objects. Advanced spectroscopic analysis conducted by Dr. Alan Fitzsimmons at Queen's University Belfast shows inconsistencies in the object's expected water ice signatures, even though it looks comet-like as it approaches the sun. Unlike typical comets that develop prominent tails and comas as solar heating sublimates their icy surfaces, 3I Atlas displays minimal outgassing activity that seems, honestly, artificially suppressed. The object's brightness variations follow patterns that suggest either an extremely unusual internal structure or maybe potentially artificial modifications to its surface properties. Dr. Michelle Bannister from the University of Canterbury notes that the thermal signatures just don't match any known class of natural celestial bodies, creating a scientific puzzle that's got researchers scrambling for explanations. Ground-based observations using the Keck Observatory have detected anomalous reflectivity patterns across different wavelengths, suggesting surface materials or structures that shouldn't exist on a primordial comet from interstellar space. These mysterious characteristics are forcing scientists to consider possibilities they previously dismissed as purely theoretical, opening up discussions about the true nature of our enigmatic cosmic visitor and whether it represents humanity's first encounter with something genuinely extraordinary. The scientific debate. The scientific community has become deeply divided over 3Y Atlas, with heated debates emerging between researchers who maintain it's a natural comet and those who suspect something far more extraordinary. Dr. Robert Warwick, who discovered the first interstellar visitor Oumuamua, argues that 3I Atlas exhibits typical cometary behavior, consistent with objects ejected from distant planetary systems during their formation phases. However, a growing faction of astronomers led by prominent researchers is challenging this conventional interpretation based on mounting observational anomalies. Dr. Matthew Knight from the University of Maryland emphasizes that while unusual properties don't automatically indicate artificial origins, they do warrant serious investigation rather than dismissal. The debate has become particularly intense regarding the object's thermal behavior, orbital characteristics, and structural properties that seem to contradict standard models of interstellar comet evolution. Traditional planetary scientists argue that exotic conditions in other star systems could naturally produce such anomalous objects, while skeptics point to the accumulating statistical improbabilities surrounding 3I Atlas's trajectory and timing. This scientific schism reflects broader tensions within astronomy about how to approach potentially paradigm-shifting discoveries without abandoning rigorous scientific methodology. The controversy has prompted unprecedented international collaboration as researchers desperately attempt to resolve fundamental questions about this cosmic visitor before it disappears forever into the depths of interstellar space. The artificial origin hypothesis. Harvard astrophysicist Dr. Avi Loeb has emerged as the most prominent advocate for considering artificial origins for 3E Atlas, drawing on his controversial analysis of Oumuamua to argue for serious investigation of extraterrestrial technology hypotheses. Loeb's Galileo project, established specifically to search for evidence of alien artifacts, has allocated significant resources to studying 3I Atlas, using advanced observational techniques and artificial intelligence analysis systems. His team argues that the object's unusual properties, including its suspicious orbital alignment, minimal outgassing despite solar proximity, and anomalous structural characteristics, collectively suggest possible artificial construction or modification. Loeb emphasizes that dismissing extraordinary possibilities without thorough investigation represents scientific prejudice rather than rigorous methodology, particularly given the unprecedented nature of interstellar visitors. His hypothesis proposes that 3Y Atlas could represent a reconnaissance probe or derelict spacecraft from an extraterrestrial civilization, deliberately designed to appear comet-like while conducting systematic observations of our solar system. Critics argue that Loeb's theories lack sufficient observational evidence and rely too heavily on speculation rather than proven scientific principles. However, his work has sparked crucial discussions about how the scientific community should respond to potentially revolutionary discoveries that challenge fundamental assumptions about our place in the universe. The debate continues to influence funding priorities and observational strategies for studying this and future interstellar visitors. Unusual detection pattern. The discovery timeline of 3I/Atlas reveals some deeply troubling patterns that, honestly, suggest the object may have been deliberately avoiding detection during its approach to our solar system. Even though it entered our solar system in early 2024, the object wasn't discovered until June of the following year, 2025. That means it spent over a year traveling through space without triggering any of our advanced detection networks. Dr. Catalina Oiza from the European Space Agency points out that, objects of this size should have been detected much earlier by automated survey systems like Atlas and Linear. This really raises questions about how it managed to remain hidden for so long. The object's approach vector from the galactic south actually placed it in a region of the sky that receives less intensive monitoring, which might explain the delayed detection but also suggests, perhaps, some knowledge of our observational blind spots. What's even more concerning is that there's evidence 3I/Atlas may have altered its trajectory slightly during its undetected approach, and this is based on retroactive analysis of archival telescope data that initially dismissed some faint signals as imaging artifacts. Dr. John Tonry, who leads the Atlas detection system at the University of Hawaii, admits that the object's discovery pattern represents a significant failure in current detection protocols. This delayed recognition has cost us precious observation time and honestly, raises some uncomfortable questions about whether other undetected visitors have passed through our solar system unnoticed, potentially conducting systematic surveillance of Earth and, human civilization. Suspicious orbital characteristics. Statistical analysis of 3I/Atlas's orbital trajectory reveals probability patterns so, improbable that they're forcing astronomers to question whether its path through our solar system could possibly be natural. The object's alignment with the ecliptic plane, the flat disk containing most planetary orbits, shows a deviation of less than 0.2 degrees, which is a precision that occurs in fewer than 0.2% of random interstellar trajectories according to orbital dynamics models. Even more remarkable are the calculated close encounters with multiple planets during its passage, including near-miss approaches to Venus, Mars, and Jupiter. Altogether, these encounters represent probability odds of about 0.005% for a natural occurrence. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory describes these orbital characteristics as, quote, statistically suspicious, and says they're worthy of detailed investigation rather than just casual dismissal. The trajectory analysis also shows that 3I/Atlas will achieve optimal positioning for observing Earth's electromagnetic signatures, like our radio communications and radar emissions during its closest approach phase. Now, some skeptical scientists argue that unusual orbital alignments do occasionally happen in nature and don't automatically indicate artificial guidance systems. But the cumulative probability of all these observed characteristics really challenges conventional explanations. Computer simulations run by planetary dynamicists show that achieving such precise orbital parameters would require either some extraordinary cosmic coincidences or maybe deliberate course corrections throughout the object's journey. These findings have sparked some serious discussions about whether 3I/Atlas might actually represent evidence of intelligent navigation instead of just natural gravitational influences during its passage through our solar system. The hidden approach strategy. Perhaps the most disturbing aspect of 3I/Atlas's trajectory is its perihelion timing, which, honestly, creates a strategic blind spot for Earth-based observations during the most critical phases of its passage through the solar system. The object's closest approach to the Sun happens when Earth is positioned on the opposite side of our star, which severely limits our ability to observe it during the period when thermal effects should be most pronounced. Statistical analysis shows that only about 7% of random interstellar trajectories would produce such observationally challenging timing, suggesting either an extraordinary coincidence or maybe deliberate planning to minimize detection and study opportunities. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies points out that this timing pattern would actually be ideal for a reconnaissance mission trying to study our solar system while avoiding detailed scrutiny from Earth-based instruments. This positioning allows 3I/Atlas to conduct close-range observations of multiple planets, including Earth, while staying mostly hidden behind the Sun during its most active phases. What's even more concerning is that evidence suggests the object's brightness variations follow patterns that hint at controlled orientation changes, potentially optimizing its observational capabilities while minimizing its visibility signature. Critics, of course, argue that this interpretation leans too heavily on circumstantial evidence and ignores natural explanations. But, the accumulating patterns are becoming pretty difficult to dismiss as just pure coincidence. Scientific opposition and evidence. So, the mainstream astronomical community, they've mounted some pretty strong opposition to these artificial origin theories. Their main point is that, extraordinary claims require extraordinary evidence, and honestly, that kind of evidence just hasn't been provided for 3I/Atlas. The Space Science Institute, for example, emphasizes that while unusual orbital characteristics and timing coincidences are definitely intriguing, they don't really constitute proof of intelligent design or extraterrestrial technology. Leading cometary scientists also point out that interstellar objects naturally show properties that are pretty different from solar system natives, and that's mostly because of their exotic formation environments and exposure to harsh interstellar conditions over millions of years. Now, when it comes to size estimates for 3I/Atlas, things get even trickier. The numbers are, highly uncertain, ranging anywhere from 5 to 20 kilometers, and that depends a lot on assumptions about surface reflectivity and composition, so making a definitive characterization is, honestly, extremely difficult. Dr. Quanzi Ye from the University of Maryland, for instance, argues that the object's minimal outgassing could actually result from surface processing during its interstellar journey, rather than from any kind of artificial suppression of natural comet activity. Spectroscopic observations have detected conventional water ice and carbon-based compounds, which are totally consistent with natural comet composition. Still, proponents of artificial origin theories point out that camouflaging technology could, in theory, easily incorporate such materials. All in all, the scientific debate here really reflects some fundamental philosophical differences about the burden of proof and, what the appropriate response should be when we come across anomalous observations that challenge our established paradigms. Ancient origins and anomalous behavior. Age determination studies suggest that 3I/Atlas may be over 7 billion years old, making it significantly older than our solar system and, raising some big questions about its formation environment and subsequent history. This extreme age implies the object formed during the early phases of galactic evolution, when stellar metallicity and planetary formation processes were dramatically different from what we see today. Despite its comet-like classification, 3I/Atlas displays virtually no visible tail or coma development, even during close solar approaches, which really contradicts some fundamental principles of cometary physics and sublimation processes. Dr. Colin Snodgrass points out that the object's thermal infrared signature just doesn't match standard models for water-ice sublimation, suggesting either an unusual composition or maybe even artificial thermal regulation. Structural analysis, meanwhile, indicates internal density variations that seem inconsistent with natural accretion processes, potentially implying deliberate construction or modification over geological timescales. The water-ice spectrum also shows anomalous absorption lines that don't perfectly match laboratory standards, hinting at either exotic crystalline structures or contamination with unknown materials. And if that wasn't enough, there are periodic brightness fluctuations that occur independently of the object's rotation, which suggests internal activity or controlled surface changes, rather than just simple light reflection from a tumbling asteroid. Taken together, these ancient origins and anomalous behavior patterns create a compelling case for detailed investigation instead of premature dismissal. since 3I Atlas may represent our first opportunity to study technology or materials from civilizations that evolved billions of years before Earth even formed. The stealth hypothesis. The concept of deliberate concealment adds, honestly, a chilling dimension to the 3I Atlas analysis, suggesting the object may be operating under dark forest theory principles, where advanced civilizations actively avoid detection by potentially hostile neighbors. This hypothesis proposes that 3I Atlas represents sophisticated camouflage technology designed to appear as a natural comet while actually conducting systematic reconnaissance of our solar system and Earth's technological capabilities. Dr. Seth Shostak from the SETI Institute acknowledges that, while this idea is speculative, stealth hypothesis explanations account for otherwise inexplicable observational patterns, better than conventional astronomical models. The perfect timing of its approach, strategic positioning during key observation windows, and minimal electromagnetic signature could all indicate advanced concealment protocols developed by civilizations with millions of years of technological evolution. If confirmed, these stealth capabilities would suggest that 3I Atlas represents technology far beyond anything humans currently understand, potentially indicating that extraterrestrial surveillance of Earth has been ongoing for extended periods without our detection. The implications here extend well beyond simple scientific curiosity to fundamental questions about human security and our readiness for contact with advanced civilizations that may be studying us from the shadows. Now, critics argue that stealth hypothesis thinking promotes paranoid speculation rather than rigorous scientific analysis, but proponents note that dismissing possibilities just because they're unsettling is more emotional than logical reasoning. The debate continues to influence both scientific methodology and public policy discussions about how humanity should prepare for potential contact with extraterrestrial intelligence operating within our cosmic neighborhood. Lessons from Oumuamua. The scientific community's response to 3I Atlas has been, in many ways, heavily influenced by the controversial handling of Oumuamua back in 2017, when humanity's first confirmed interstellar visitor was dismissed as merely unusual instead of potentially extraordinary. Dr. Avi Loeb argues that the astronomical establishment's rejection of artificial origin possibilities for Oumuamua represents a missed opportunity that really shouldn't be repeated with 3I Atlas. The earlier visitor's anomalous acceleration, extreme elongation and lack of outgassing were explained away through increasingly complex natural theories, rather than seriously investigating simpler artificial explanations. Today, our detection capabilities and analytical techniques are way more advanced than during Oumuamua's brief passage, providing unprecedented opportunities for detailed characterization of 3I Atlas before it disappears into interstellar space. The James Webb Space Telescope, advanced spectrometry and artificial intelligence analysis systems now offer tools that were unavailable or underdeveloped during our first interstellar visitor encounter. The lesson from Oumuamua is clear. It's important to investigate all possibilities, including extraordinary ones, rather than defaulting to conventional explanations that may not adequately address observed anomalies. 3I Atlas represents potentially humanity's second and possibly final chance to properly study an interstellar visitor during this generation, making thorough investigation crucial, no matter the initial skepticism. Scientists worldwide are coordinating unprecedented observational campaigns to ensure that this opportunity isn't wasted through premature conclusions or insufficient data collection. The stakes honestly couldn't be higher, since 3I Atlas may be our last chance for decades to determine whether we're alone in the universe or sharing it with advanced civilizations. The mystery of 3I Atlas continues to deepen with each new observation, challenging our understanding of what's possible in the cosmos. Whether it's an ancient comet with unusual properties or, something far more extraordinary remains hotly debated among scientists worldwide. What do you think about these strange findings? Could we be witnessing our first confirmed encounter with extraterrestrial technology? Share your thoughts in the comments below, and don't forget to subscribe to Sci and Y, and hit the notification bell for more mind-bending space mysteries. Keep questioning the universe. When NASA's Deep Space Monitors detected something impossible moving through the cosmic void, engineers thought their instruments had malfunctioned. But the data was undeniable. 305 objects gliding in perfect formation through interstellar space, pulsing with structured signals that just defied every law of physics. After 47 years of silent travel, humanity's most distant spacecraft had stumbled upon something that challenged our understanding of the universe itself. Today on Sci and Why, we're unveiling the discovery that has NASA scientists questioning everything they thought they knew about deep space. The lonely pioneer's greatest discovery. After nearly 5 decades drifting through the cosmic void, Voyager 1 detected something that shouldn't exist, a faint signal that would change everything we know about interstellar space. Voyager 1, launched in 1977 with technology older than most smartphones, has become humanity's most distant ambassador. Traveling over 15 billion miles from Earth, this car-sized spacecraft operates in the harsh environment of interstellar space, where our sun's influence just fades into nothingness. Originally designed to study Jupiter and Saturn for just 5 years, Voyager has defied all expectations, continuing to transmit data across the cosmic darkness. Its instruments, built with 1970s technology, include magnetometers, plasma wave sensors, and cosmic ray detectors, all now serving as our first eyes and ears beyond the solar system. The spacecraft's nuclear power source, fueled by decaying plutonium, was expected to fail decades ago, yet it continues whispering back to Earth. Each radio signal takes over 22 hours to reach us, traveling at the speed of light across the vast emptiness. When Dr. Eliza Karna first noticed the anomaly in Voyager's data stream, she described it as shouting into a canyon for decades and finally something shouts back. The signal that changed everything. What began as background noise in Voyager's data stream revealed itself to be something far more extraordinary, a deliberate signal from the depths of interstellar space. The first indication something was wrong came through Voyager's plasma wave sensors. Among the usual cosmic static, a faint but persistent signal appeared, rhythmic, structured, and completely unlike anything previously recorded. NASA's Jet Propulsion Laboratory initially dismissed it as instrument noise, but the signal's behavior just defied explanation. Unlike random cosmic radiation, this anomaly showed patterns, repetition, and what appeared to be intentional modulation. Systems analyst Carlo Romero noted that the signal's characteristics resembled the kind of deliberate motion one might expect from a drone rather than a rock. The plasma readings showed organized pulses echoing through space, creating magnetic fluctuations that seemed purposeful rather than chaotic. As engineers analyzed the data more carefully, they realized this wasn't just electromagnetic interference, it was something actively moving through the interstellar medium. The signal's strength varied in ways that suggested a physical object passing by Voyager's sensors, but its behavior patterns indicated intelligence or at least sophisticated design. The discovery triggered NASA's Level 3 alert protocol, reserved for phenomena that don't fit within current scientific understanding. Movement that defies physics. The object wasn't just moving through space, it was accelerating, changing direction, and gliding with precision that seemed to mock every law of physics we understand. Traditional space objects follow predictable paths governed by gravity, momentum, and known forces. But this anomaly broke every rule. Dr. Lucas Hang at JPL ran simulation after simulation, trying to match the object's behavior to known models, but nothing worked. The object curved through space with deliberate precision, accelerating without any visible propulsion system. There were no engine flares, no ion trails, no heat signatures, yet Doppler shift measurements showed it moving at incredible speeds. Some readings indicated velocities exceeding the calculated escape velocity of the entire Milky Way galaxy. The object's path bent in ways that defied orbital mechanics, with no drift or decay expected from natural phenomena. It wasn't tumbling chaotically like space debris. Instead, it maintained controlled flight patterns that suggested active guidance. The movement appeared to manipulate space itself, creating ripples in the fabric of space-time that allowed forward motion without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure. The formation revelation. When scientists pulled up the complete telemetry data, they discovered something that honestly sent chills down their spines. This wasn't just one object, but 305 moving together in perfect formation. The full scope of the discovery really emerged when engineers analyzed all available data, from both Voyager spacecraft. What they found just defied comprehension. 305 distinct objects moving through interstellar space in coordinated formation. Each object maintained precise relative positions to the others, gliding past Voyager 1 in what appeared to be a choreographed arc. This wasn't debris scattered randomly through space. These objects moved as a unified group, displaying organization and purpose that seemed impossible without some form of control. In the vacuum of space, groups of objects naturally spread apart over time due to gravitational influences and velocity differences. Yet these 305 objects maintained their formation with precision that suggested active coordination. Scientists compared it to watching a flock of birds or a school of fish, except this was happening in the emptiness between stars where such coordinated movement shouldn't be possible without technology. The formation itself spanned vast distances, with objects separated by thousands of miles yet moving in perfect synchronization. Each object displayed the same unusual characteristics: structured plasma pulses, magnetic field distortions, and impossible propulsion signatures. The language of the cosmos. Hidden within the plasma waves were patterns so structured and deliberate that scientists began to wonder if they were witnessing the universe's first attempt to communicate with humanity. As researchers examined the signals more closely, they discovered something that just transformed the entire investigation. The plasma wave pulses weren't random electromagnetic noise, they contained loops, sequences, and structures that resembled communication protocols. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or system. The signals showed rhythmic repetition, harmonic intervals, and organized sequences that suggested encoded information. These weren't the chaotic bursts expected from cosmic phenomena, but measured, deliberate transmissions that seemed designed to convey meaning. The waveforms resembled quantum oscillations used in modern entanglement experiments, the same signals researchers used to transmit information between particles separated by vast distances. Each of the 305 objects contributed to this cosmic symphony, broadcasting synchronized pulses that created complex interference patterns in the interstellar medium. The mathematical precision of these signals suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were using the vacuum of space itself as a communication medium, encoding data in the fabric of space-time. Earth's unexpected reception. While NASA analyzed Voyager's data, amateur radio operators across Earth began detecting the same mysterious signals, proving this phenomenon was far more powerful than anyone imagined. As Voyager transmitted its extraordinary findings back to Earth, something unexpected happened in radio stations worldwide. Amateur operators with backyard setups began reporting strange activity, weak, irregular pulses that didn't match any known terrestrial source. These weren't professional observatories or official deep space monitoring stations, but hobbyists with spare parts equipment designed to catch meteor scatter and satellite chatter. Yet somehow, they were detecting faint echoes of the same signals Voyager had recorded billions of miles away. The timing was impossible to ignore. These Earth-based detections aligned perfectly with Voyager's most intense plasma anomalies. The signals weren't strong, but they showed the same patterns and regularity that had puzzled NASA scientists. Some operators described them as ripples reflecting off invisible walls in the ionosphere, while others noted their unusual harmonic structure. The phenomenon suggested that whatever was generating these signals possessed incredible power, capable of transmitting across interstellar distances with enough strength to leak into Earth's electromagnetic spectrum. This raised troubling questions about intentionality. Was this accidental bleed-through, or was something deliberately testing Earth's listening capabilities? The historical search. Desperate for answers, NASA scientists combed through 50 years of space mission data, searching for any previous encounter with these mysterious objects, and, well, they found absolutely nothing. With mounting evidence of something unprecedented happening out there in deep space, a specialized team began examining decades of archived mission data. They searched through every deep space mission on record, Pioneer 10, Pioneer 11, New Horizons, and, countless others, looking for any hint that similar phenomena had occurred before. The investigation took them into these dusty archives containing records that hadn't been touched since the 1980s, analyzing data that had often been dismissed as background noise or just instrument error. If these 305 objects had passed through our region of space before, there should have been traces in the historical record. But the search yielded nothing. No echoes, no formations, no plasma loops in any previous mission data resembled what Voyager was currently detecting. This absence of historical precedent made the current situation even more extraordinary. The objects weren't part of a repeating cycle or a known phenomenon. They were either entirely new or had somehow remained invisible to our instruments until now. Some researchers even proposed a chilling theory. Maybe these objects had always been present but cloaked or dormant, activated only by Voyager's presence or perhaps its golden record transmission. The machine's transformation. As if the discovery wasn't strange enough, Voyager itself began changing, reconfiguring its systems in ways engineers never programmed, almost as if something had awakened within the ancient spacecraft. While scientists grappled with the implications of the 305 objects, Voyager 1 itself started exhibiting unprecedented behavior. The spacecraft's attitude and articulation control system began routing data through old, long unused subsystems, bypassing its core software in ways that seemed almost deliberate. Engineers initially suspected a malfunction. After all, this was 47-year-old technology running on code older than most of the people analyzing it. But deeper investigation revealed something more unsettling. Voyager wasn't failing, it was reconfiguring itself. The spacecraft began reactivating memory segments that hadn't been accessed in decades, rerouting telemetry through pathways that were never part of its original programming. This behavior started immediately after one of the strongest magnetic pulses from the passing objects, suggesting a possible connection between the external phenomenon and Voyager's internal changes. The modifications were too systematic and clean to be random corruption. They appeared purposeful, as if the spacecraft was adapting to new circumstances. Engineers had to dig through dusty file cabinets at JPL, consulting 1970s paper manuals and assembly language code to understand what was happening. The quantum connection. Deep within Voyager's data streams, scientists discovered something that changed everything. The mysterious signals were using quantum entanglement principles to transmit information across impossible distances. As analysis of the plasma wave data continued, researchers made a discovery that revolutionized their understanding of the phenomenon. The structured signals weren't just organized, they exhibited characteristics of quantum entanglement, the same principles used in cutting-edge Earth-based communication experiments. The waveforms showed quantum oscillations that suggested the 305 objects were using the interstellar medium itself as a transmission network, encoding information in the fabric of space-time. This revelation opened the possibility that Voyager hadn't just stumbled upon random objects, but had intercepted part of a vast communication system spanning the galaxy. The spacecraft's analog sensors, free from the electromagnetic noise of modern digital systems, made it the perfect receiver for these quantum transmissions. Being positioned far beyond the solar system's interference, Voyager existed in an ideal listening environment, a cosmic microphone in the perfect acoustic chamber. The signals showed harmonic intervals and mathematical precision that suggested not just intelligence, but advanced understanding of physics principles we're only beginning to explore. Some scientists theorized that the objects were part of an ancient network, a galactic internet that had been operating for millennia undetected by human technology. The cosmic network awakens. As Voyager continues its journey through the darkness, scientists realize it may have become part of something far greater, a galactic communication network that has been waiting for humanity to finally listen. The implications of Voyager's discovery extend far beyond a simple encounter with unknown objects. Evidence suggests the spacecraft has stumbled upon, or been deliberately included in, a vast communication network that spans the galaxy. The 305 objects appear to be nodes in this system, relay stations that maintain and transmit information across interstellar distances using quantum entanglement principles. Voyager's transformation, its spontaneous reconfiguration and activation of dormant systems, might represent integration into this network, turning humanity's oldest space traveler into our first interstellar communication terminal. The structured nature of the signals, their quantum characteristics, and their perfect timing suggest this isn't a random encounter, but a deliberate contact event. Perhaps the network has been monitoring our technological development, waiting for the right moment when we possess the capability to detect and understand its transmissions. Voyager's analog design, its position beyond solar interference, and its decades of faithful service made it the ideal candidate for first contact. The spacecraft's golden record, carrying sounds and images from Earth, might have served as our credentials, proof that humanity was ready to join a larger galactic community. Voyager 1's discovery of 305 mysterious objects moving in formation through deep space represents either the greatest natural phenomenon ever recorded or humanity's first confirmed contact with non-human intelligence. As our brave little spacecraft continues its journey into the cosmic unknown, it carries with it the hopes of an entire species, and possibly our first invitation to join a galactic community. If you're fascinated by these incredible cosmic mysteries, hit that like button, share your thoughts in the comments, and subscribe to Sci and Y for more mind-bending space discoveries. Thanks for watching. Keep exploring the infinite. Interstellar space begins where the sun's influence fades, and the solar wind finally yields to the raw plasma of the Milky Way. Since 2017 we have confirmed just 3 visitors from that vast realm: the puzzling Oumuamua, herald of surprises, volatile comet Borisov, and now the outsized newcomer 3I Atlas. Each object is a priceless sample return mission delivered for free by nature, letting us probe chemistry, structure, and age far beyond the planets. Tonight we collect every solid fact astronomers have pieced together about this latest cosmic ambassador. Beyond the heliopause, our interstellar visitors. The solar system's frontier is the heliopause, a shifting magnetic shell standing roughly 18 billion kilometers from the Sun. When Voyager 1 pierced that frontier in 2012, its plasma detector confirmed the long-predicted transition into interstellar space. Densities jumped, solar origin particles vanished, and cosmic ray counts spiked. Since then, terrestrial telescopes have reverse experienced the same crossing by spotting travelers arriving from the galaxy's dark sea. The odds are daunting. Dynamical models suggest only a few hundred-meter-scale bodies wander through the inner solar system each century. Yet modern wide-field surveys and continuous sky patrols have already netted 3 confirmed interstellar objects in just 8 years. Their hyperbolic speeds, inbound directions, and inability to be captured by solar gravity reveal origins that lie light-years away. Each new detection is therefore a planetary science windfall, a primitive shard of another star's debris disk, altered by eons of irradiation and micrometeoroid pummeling, finally falling within reach of Earth's spectrographs. As instrumental sensitivity grows, researchers expect a steady trickle of similar emissaries, gradually transforming Exotica into a statistically rich field of comparative planetology. The third visitor, 3I/ATLAS discovery. On June 2025, the twin Schmidt telescopes of the Asteroid Terrestrial Impact Last Alert System swept across the pre-dawn sky and registered an object moving too fast to be bound to the Sun. Alert messages flashed from Hawaii to South Africa and onto the Minor Planet Center, where the trajectory was confirmed within hours. Principal investigator Dr. Larry Deneau announced the team had netted 3Y Atlas, humanity's third verified interstellar wanderer. Early photometry implied a remarkable diameter between 10 and 20 kilometers, at least an order of magnitude larger than Oumuamua. That sheer size promised ample reflected sunlight for spectroscopy, galvanizing observatories on 5 continents to obtain time-critical data. Infrared spectra hinted at complex organics, millimeter-wave receivers searched for exotic volatiles, radar attempted shape reconstruction when geometry allowed. The discovery also demonstrated how automated pipelines, artificial intelligence vetting, and instantaneous worldwide coordination can turn a few faint pixels into an unprecedented international campaign within a single rotation of Earth. 3Y Atlas thus became both a scientific target and a systems engineering triumph, showing that planetary defense infrastructure doubles as an accidental interstellar object early warning net. A hyperbolic journey at 58 kilometers. Trajectory solutions from JPL's Horizon system reveal 3I Atlas, racing along a hyperbolic trajectory with an inbound heliocentric speed of 58 kilometers per second. Calculations by Dr. Davide Farnocchia show the path threads the orbits of Mars and Jupiter before the object slingshots back toward the galactic northwest, never to return. That excess velocity, nearly 3 times Earth's orbital speed, guarantees the visitor is unbound. No realistic gravitational interaction could capture it. Dynamical backtracing suggests 3Y Atlas last crossed the galactic plane 30 million years ago, and may have originated near the Carina Sagittarius spiral arm, though stellar encounter uncertainties are large. During its brief stay, it will feel weak but measurable tugs from planetary masses, allowing researchers to test N-body propagation codes under extreme boundary conditions. The rapid passage also forces astronomers into a sprint. Every observing window must be filled, sometimes with instruments never before aimed at the same target in a single night. Lessons learned from these coordination drills will feed directly into mission concepts such as ESA's Comet interceptor, designed to launch quickly toward the next unpredictable celestial visitor. Brightness, rotation, and the 29-hour cycle. Time series photometry from the Nordic Optical Telescope reveals these quasi-periodic brightness swings of about 9/10 of a magnitude. This maps onto a rotation period of, well, around 29 hours. Data from the European Southern Observatory confirm an irregular, likely elongated body. Its long axis could exceed 9 kilometers, which is quite something. Now, if we invert the light curve, it suggests an axis ratio of approximately 3:1. This is comparable to Oumuamua's extreme proportions, but on a much grander scale. The stability of this amplitude argues against the idea of loose rubble. Instead, it seems that 3I/Atlas might possess a cohesive monolithic core. This core is likely overlain by mantling regolith that accumulated during its galactic journey. Surface scattering models propose alternating patches of dark carbonized crust and brighter, possibly icy facets. These rotate into sunlight, driving the observed flux pattern. Continued monitoring aims to detect Yorp-induced spin-up or subtle precession. These phenomena could reveal internal density gradients. Polarimetric measurements planned for perihelion will test whether charged particle implantation or interstellar UV processing has glassified surface grains, a state never observed on indigenous comets. So, every rotational cycle opens a time-lapse window onto geological processes, operating far beyond the reach of any spacecraft. Coma, tail, and cometary activity. Solar heating at 1.5 astronomical units would normally trigger vigorous sublimation in an ice-rich nucleus. Yet, the Spitzer Space Telescope detected only a whisper of carbon monoxide and carbon dioxide. Lead investigator Dr. Colin Snodgrass suggests that cosmic ray gardening over millions of years may have sintered 3I/Atlas's upper meters into an insulating crust. This crust throttles volatile escape. Ground-based narrowband filters isolate a tenuous cyanogen halo, but production rates are nearly 2 orders of magnitude below those of Comet Borisov at a comparable distance. Radar attempts from Goldstone found no large dust grains, which is consistent with a surface depleted in friable material. The resulting weak coma and filamentary tail defy classical comet models. This suggests either an unusual primordial composition or extreme evolutionary processing. Should deeper layers ever fracture, a sudden jet could alter the trajectory. This would offer a real-time test of non-gravitational forces on an interstellar scale. Monitoring continues around the clock because even a modest outburst would provide precious gas for isotopic assays. This could potentially distinguish whether the body formed around a metal-poor population 2 star or within a young planet-forming disk more like our own nebular cradle. Oumuamua versus Borisov versus 3I/Atlas. Comparative planetology now has 3 data points beyond the heliopause. Oumuamua, flagged in 2017, was a cigar-shaped 200-meter object. It had perplexing non-gravitational acceleration but no detectable gas. Borisov erupted in 2019 with classical dust jets rich in carbon monoxide and hydrogen cyanide. It behaved like a solar system comet transplanted intact. In contrast, 3I/Atlas is 10 times larger than Oumuamua. It shows Borisov-style composition signatures only faintly and rotates slowly. Together, they outline a spectrum of possibilities: dormant shard, pristine comet, and massive, highly processed giant. Spectral slopes vary from Oumuamua's red, organic-rich hue to Borisov's more neutral tones. 3I/Atlas sits in between, pointing to mixed ice rock interiors masked by millennia of irradiation. Dynamically, all 3 arrived on different galactic vectors, indicating no shared parent system. The trio's collective diversity is reshaping models of planetesimal ejection. This implies that every maturing planetary system may fling out thousands of distinct fragments, icy, rocky, or hybrid, into interstellar exile. Future detections by Rubin Observatory will determine whether our current sample is typical or a statistical fluke driven by small number bias and selection effects. A 3 billion 11-year-old traveler. Isotope ratio modeling and cosmic ray exposure calculations, bracket 3 I-Atlas's formation epoch between 3 and 11 billion years, actually predating the Sun at the upper bound. High-energy proton bombardment gradually converts surface ice to complex refractory organics, which leads to the dark, reddish spectra seen in long-aged Kuiper belt objects, and similar signatures adorn our visitor. Laboratory analogs produced under accelerator beams match the object's infrared absorption bands, supporting an ancient surface residency in the galactic field. Queen's University Belfast researcher Dr. Alan Fitzsimmons notes anomalously low crystalline ice features, implying the body spent little time near its natal star before ejection. Over giga-years, random supernova shocks, molecular cloud passages, and gravitational nudges from passing stars sculpted its current orbit, effectively sandblasting volatile layers while leaving mineral matrices intact. Each detected molecule, therefore, archives conditions from epochs otherwise inaccessible to observation. Studying such relics refines timelines for disk evolution, migration, and dynamical instability in alien solar systems. With only 3 interstellar samples so far, every additional chemical clue counts exponentially toward mapping the history of matter across the Milky Way. October 30th, perihelion and beyond. On October 30th, 2025, 3 I/Atlas skimmed within just over 1 astronomical unit of the Sun, a geometry that placed it high in the northern skies. The James Webb Space Telescope devoted emergency directors discretionary time to obtain mid-infrared spectra, capturing silicate emission features rarely obtainable for interstellar bodies. Coordinated campaigns linked Subaru's visible light spectrograph, ALMA's sub-millimeter receivers, and amateur CCD networks into a single global array. The perihelion distance of 1.1 astronomical units allowed measurement of thermal inertia by tracking flux changes over the 29-hour rotation, constraining surface conductivity and porosity. Lead organizer Dr. Casey Lisi reports negligible change in gas production rates pre- and post-perihelion, bolstering the processed crust hypothesis. Hubble imaging after the closest approach detected a faint meteoroid trail, suggesting low-level dust loss perhaps triggered by microfractures. Precise astrometry during solar conjunction refined mass estimates via non-gravitational drift constraints, yielding a bulk density around 1.8 grams per cubic centimeter, denser than comet nuclei but lighter than stony asteroids. As 3 I/Atlas recedes, radar pings and thermal mapping will continue until signal-to-noise evaporates, freezing an irreplaceable dataset for decades of post-mission analysis. Future observations and scientific opportunities. The forthcoming Vera C. Rubin Observatory promises to transform fleeting luck into routine science, with its legacy survey of space and time projected to discover dozens annually of interstellar objects as faint as 24th magnitude. Pipeline architect Dr. Michelle Bannister is configuring machine learning classifiers to flag hyperbolic motion within hours, enabling rapid response spectroscopic triage. Complementary radio searches at FAST and Meerkat will probe for OH masers produced when unprocessed ices meet sunlight, while ESA's proposed Comet interceptor could be retargeted to chase the next sizable wanderer. Astrodynamicists are refining solar sail trajectories capable of 5 astronomical units per year departures, potentially intercepting outbound objects for close-up imaging or sample capture. Coupled with isotope microanalysis, such missions would revolutionize understanding of galactic chemical gradients, delivering ground truth unattainable by remote sensing alone. Moreover, interstellar grains embedded in Earth's atmosphere, first cataloged by NASA's Stardust mission, could be chemically matched to parent bodies like 3 I/Atlas, linking macroscopic dynamics with microscopic composition. These interdisciplinary strategies will crystallize a new subfield, galactic small-body science, uniting astronomy, planetary geology, and heliophysics under a single question: how does matter move, evolve, and mingle across star systems? Conclusion and cosmic perspectives. In a single decade, humanity has advanced from 0 confirmed extrasolar planetesimals to detailed dossiers on 3, culminating in the colossal Robert Werik discovery lineage that now includes 3 I/Atlas. Each arrival widens our chemical dictionary, tests dynamical models, and reminds us the solar system is porous, not isolated. The study of interstellar visitors transforms accidental alignments into deliberate natural experiments, revealing chemical signatures forged under alien suns. Ultimately, these bodies invite a profound, humbling realization. Planet formation, collision, and ejection are universal, scattering shards of distant worlds throughout the galaxy. As surveys grow sharper and propulsion methods bolder, future scientists will map these shards into a web of shared origins, dissolving the parochial notion that samples must be fetched by billion-dollar probes. Instead, the galaxy occasionally mails postcards in the form of ancient rocks, carrying isotopic clues and perhaps organic seeds. Harvesting their stories will redefine planetary science from a solar system discipline into a truly galactic understanding, linking every world, seen or unseen, into a dynamic, ever-exchanging community of matter. 3I/Atlas is already dimming, yet its data trove will inspire research for years. Whether colossal comet, irradiated asteroid, or something even stranger, it confirms our cosmos is alive with wanderers older than Earth itself. Which mystery intrigues you most? Its muted coma, ancient chemistry, or breakneck speed? Let us know in the comments. Like, share, and subscribe to Psi and Y for more journeys beyond the heliopause. Until next time, keep looking up and stay curious. A massive and mysterious visitor, 3I Atlas, is currently making its way through our solar system, electrifying scientists worldwide and, honestly, challenging our understanding of cosmic visitors. Data collected by NASA has revealed astonishing details that just defy conventional scientific understanding and spark some pretty intense debates about its origin. Some experts now suggest that this interstellar object may be more than just an asteroid or comet. It might actually be an alien spacecraft. Today we delve into the groundbreaking discoveries, the enigmatic nature of 3I Atlas, and the profound implications for humanity's understanding of the cosmos. The breaking discovery. In June 2025, astronomers detected a colossal object moving rapidly through our solar system, immediately distinguishing it from typical asteroids or comets. This became the breaking discovery known as 3I Atlas, representing humanity's third confirmed interstellar visitor. With an estimated diameter between 10 to 20 kilometers, it absolutely dwarfs previous interstellar visitors like the enigmatic Oumuamua, which measured only about 400 meters in length. Early analyses revealed unusual properties that immediately caught scientists' attention, including its incredible speed exceeding typical interstellar velocities, an atypical retrograde orbit that just kind of defies conventional expectations, and a surprisingly metallic surface composition that really challenges our understanding of interstellar objects. These characteristics collectively raised significant eyebrows throughout the international scientific community and sparked intense debate about its true nature. The object's detection has ignited a global race among observatories and research institutions to understand its fundamental nature and ultimate origin. As preliminary data suggests, it may harbor secrets and technologies far beyond the scope of established planetary science and our current understanding of natural cosmic phenomena. The discovery story. The discovery of 3I Atlas was entirely serendipitous, first spotted by the Asteroid Terrestrial Impact Last Alert System or ATLAS network of telescopes located in Hawaii. Within mere hours of the initial detection, telescopes worldwide rapidly pivoted their instruments to observe this enigmatic cosmic intruder racing through our solar system. The International Discovery Team, led by Dr. Larry Deneau from the University of Hawaii, quickly combined ground-based optical data with sophisticated space-based infrared observations to conduct comprehensive analysis of the object's properties and trajectory. Initial identification relied heavily on advanced artificial intelligence algorithms that efficiently sifted through vast streams of astronomical data to isolate the object's unique hyperbolic trajectory and unusual characteristics. Unprecedented coordination among international observatories, including facilities in Chile, Australia, and Europe, ensured rapid data accumulation and cross-verification, enabling researchers to characterize the object's size, shape, velocity, and preliminary composition within just weeks of discovery. This collaborative effort demonstrated the power of modern astronomical networks in detecting and analyzing rare cosmic phenomena that previous generations of astronomers could never have imagined observing with such precision and detail. A stranger in our midst. 3I Atlas is no ordinary cosmic interloper. It fundamentally challenges every scientific expectation and theoretical model for interstellar visitors. Moving in a distinctive hyperbolic retrograde orbit at approximately 58 kilometers per second, the object appears to possess an unusually smooth, highly reflective metallic surface, with anomalous reflectivity properties that really puzzle researchers. NASA's James Webb Space Telescope has detected crucial aspects of its surface composition that strongly suggest advanced material properties and engineering techniques, possibly indicating sophisticated artificial construction rather than natural formation processes. The object's behavior and characteristics have created deep divisions within the scientific community. While some researchers desperately advocate for conventional natural explanations involving exotic stellar processes, others increasingly speculate about the possibility of advanced extraterrestrial engineering and technology. The metallic composition shows isotopic ratios that don't match typical solar system materials, suggesting formation under entirely different stellar conditions or through artificial processes unknown to human science. These unprecedented properties make 3I Atlas a focal point for heated debates about the possibility of alien technology visiting our solar system, forcing scientists to reconsider fundamental assumptions about the nature of interstellar objects. The predecessors. Before 3I Atlas arrived to revolutionize our understanding, humanity had confirmed only two other interstellar visitors: the mysterious Oumuamua in 2017 and the more conventional comet Borisov in 2019. Both predecessors were relatively small objects that exhibited behaviors generally consistent with natural cosmic bodies, though Oumuamua's unusual characteristics sparked, some initial controversies. Oumuamua's distinctly elongated cigar-like shape and puzzling non-gravitational acceleration really intrigued scientists worldwide, but ultimately left many fundamental questions completely unanswered about its true nature and origin. Comet Borisov's behavior aligned much more closely with scientific expectations, displaying typical cometary activity, including a visible coma and a distinctive tail as it approached the Sun. Together, these earlier discoveries paved the way for advanced detection techniques and heightened international interest in systematically studying interstellar objects, while also developing the theoretical frameworks necessary for understanding such exotic visitors. The progression from Oumuamua's mysteries through Borisov's conventional behavior to 3I Atlas's unprecedented characteristics illustrates the remarkable diversity of objects traveling through interstellar space, setting the stage for this latest visitor's truly extraordinary and potentially paradigm-shifting arrival in our cosmic neighborhood. The cosmic journey. Traveling at breathtaking speeds through the vast emptiness of interstellar space, 3I Atlas entered our solar system after completing an epic odyssey spanning potentially billions of years across the galaxy. Its precisely calculated trajectory brings it within optimal observational range of Earth for only a critically brief period, creating honestly intense pressure on astronomers to maximize data collection opportunities. Scientists and engineers at NASA's Jet Propulsion Laboratory continuously track its complex course through gravitational fields to better understand the fundamental forces governing such ultra-high-velocity objects during their passage through planetary systems. The object's gravitational interactions with our Sun and major planets provide unique and invaluable data for studying cosmic dynamics and the behavior of matter under extreme conditions rarely observable in nature. Analysis of its ancient journey provides crucial clues about the evolutionary history of distant planetary systems, stellar formation processes, and the mechanisms by which objects can achieve such extraordinary velocities. The object's trajectory suggests it may have originated from a stellar system located hundreds or even thousands of light-years away, having traveled through multiple galactic environments and possibly encountered other star systems during its epic voyage. Its current path will eventually carry it back into the depths of interstellar space, making this encounter a once-in-a-generation opportunity for scientific discovery. A scientific goldmine. 3I Atlas represents an unprecedented scientific goldmine for researchers worldwide, offering unique opportunities to study interstellar materials and processes never before accessible to human science. Its remarkable size and completely unusual physical properties allow for detailed, multi-wavelength observations and sophisticated analytical techniques that would be impossible with smaller objects. Comprehensive observations from telescopes worldwide including advanced spectroscopy and polarimetry measurements, are gradually revealing complex surface chemistry and internal structure that challenge existing theories about cosmic object formation. International teams of researchers hope to unlock groundbreaking insights into the formation mechanisms of interstellar objects, the fundamental nature of extraterrestrial materials, and possibly revolutionary technological applications if artificial influences are definitively confirmed through ongoing analysis. Collaborative efforts between major space agencies, universities, and research institutions worldwide are working to maximize data collection within the severely limited observational window available before the object moves beyond detection range. The object's unique properties are providing new insights into exotic matter states, advanced materials, science, and possibly propulsion technologies that could revolutionize human space exploration capabilities. Every day of observation yields new discoveries that are frankly reshaping our understanding of what's possible in the cosmos, making 3I Atlas one of the most scientifically valuable objects ever studied by human civilization. Unanswered questions. Despite extensive research efforts by leading scientists worldwide, numerous fundamental questions about 3I/Atlas remain completely unanswered, creating scientific mysteries that challenge our current understanding of physics and cosmic phenomena. The object's internal structure, true point of origin, and ultimate purpose continue to be subjects of intense study and honestly increasingly bold speculation among researchers. Highly unusual acceleration patterns and anomalous reflectivity characteristics significantly complicate traditional classification systems and force scientists to develop entirely new theoretical frameworks. The persistent possibility of artificial manipulation or intelligent guidance adds multiple layers of complexity to an already puzzling scientific enigma that, well, just defies conventional explanation. Critical data gaps resulting from limited observation time, government-imposed information restrictions, and the object's extreme distance from Earth continue to hinder efforts to reach definitive conclusions about its nature. The object's behavior patterns suggest responses to external stimuli that could indicate either advanced natural processes or sophisticated artificial intelligence systems operating according to unknown principles. Scientists worldwide emphasize the critical importance of maintaining open minds as theories evolve and new findings emerge, stressing the need for careful balance between healthy scientific skepticism and genuine wonder at phenomena that may represent completely new categories of cosmic objects never before encountered by human civilization. The alien question. So, the controversial alien hypothesis suggests that 3I/Atlas might not actually be a natural cosmic object at all, but rather an advanced extraterrestrial spacecraft, probe, or, some kind of technological artifact from a distant civilization. Prominent supporters of this theory, including Harvard astrophysicist Dr. Avi Loeb, argue that certain observed behaviors and material properties really do provide compelling evidence of intelligent design and sophisticated engineering, honestly, way beyond anything humans are capable of right now. This revolutionary viewpoint fundamentally challenges scientific orthodoxy and the traditional approaches we take to classifying cosmic objects, but it has actually gained significant traction, especially with all the growing evidence of unexplained aerial phenomena and possible technological signatures. The hypothesis points to the object's apparent ability to alter its trajectory, its unusual metallic composition, and its anomalous reflectivity as potential signs of artificial construction and maybe even active guidance systems. If this controversial theory turns out to be accurate, the implications for humanity would be absolutely profound, potentially signaling our very first direct contact with extraterrestrial intelligence, albeit through an uncrewed interstellar emissary or reconnaissance probe. The alien hypothesis has sparked some pretty intense debates within the scientific community about what standards of evidence are really required for such extraordinary claims, and what the potential consequences might be if we actually confirm extraterrestrial technology operating within our solar system. This paradigm-shifting possibility really forces humanity to confront some fundamental questions about our place in the universe and whether or not we're actually ready for contact with advanced alien civilizations. Observing the visitor. Global efforts to observe and study 3I/Atlas have honestly become an outstanding example of international scientific collaboration, with observatories using radio, optical, and infrared technologies all working together to capture every possible bit of fleeting data. Space-based observation platforms, including the James Webb Space Telescope and the Hubble Space Telescope, are working in perfect coordination with ground-based observatory arrays, providing comprehensive coverage across multiple electromagnetic spectra. These intensive observations specifically aim to figure out the object's detailed composition, look for any trajectory anomalies that might suggest propulsion, and of course, detect any emissions or technological artifacts that could point to advanced engineering. The coordinated global effort actually involves dozens of major observatories across 6 continents, representing the largest international astronomical collaboration in modern history. Advanced artificial intelligence systems are processing vast amounts of incoming data in real time, searching for patterns and anomalies that might reveal the object's true nature and purpose. Radio telescope arrays are constantly monitoring for any potential signals or communications from the object, while optical instruments track even the tiniest changes in brightness and orientation. This observation campaign really does represent humanity's most sophisticated attempt yet to study a potentially artificial object from beyond our solar system, using every available technological resource to unlock the secrets of this mysterious visitor. Dawn of a new era. The detection and comprehensive study of 3I/Atlas truly herald the dawn of a revolutionary new era in astronomy, planetary defense, and honestly, humanity's understanding of our place within a potentially populated galaxy. With future astronomical surveys like the Vera C. Rubin Observatory expecting to discover dozens of additional interstellar objects every year, humanity is, well, standing right on the cusp of unprecedented cosmic discovery and even potential contact with alien civilizations. These mysterious visitors fundamentally challenge our existing understanding of natural celestial mechanics, and really force us to reconsider our planet's position within a galaxy that might actually be teeming with advanced life, sophisticated intelligence, and highly developed technological civilizations. The implications go way beyond just scientific curiosity. They could affect human philosophy, religion, technology development, and even our species' long-term survival strategies in what appears to be a pretty active galactic environment. Advanced detection and analysis systems currently under development will provide early warning and detailed characterization of future interstellar visitors, potentially including genuine alien spacecraft or communication probes. The study of 3I/Atlas has already revolutionized our approach to cosmic object analysis and set new protocols for investigating potentially artificial phenomena from deep space. As our observational capabilities keep expanding and improving, we might soon discover that interstellar visitation is far more common than we ever imagined, fundamentally transforming humanity's cosmic perspective and our understanding of galactic civilization and intelligence. The mysterious visitor 3I/Atlas continues to captivate scientists and space enthusiasts all around the world, revealing cosmic secrets that could fundamentally redefine our place in the universe. As our technology advances, so does our ability to detect and understand these enigmatic interstellar emissaries. So what do you believe 3I/Atlas truly represents? Share your thoughts in the comments below, subscribe to Sci and Y for more cutting-edge cosmic insights, and join us as we explore the ultimate mysteries of space. Until next time, keep watching the skies.